today we are welcoming Jag and Jing to talk about enabling responsible generative AI adoption, insights from MIDAS at the University of Michigan. So Dr. Jing Liu is the executive director of the Michigan Institute for Data and AI in Society at the University of Michigan. Dr. Liu's work focuses on building institutional capacity for academic research with emerging technologies, especially artificial intelligence, ensuring the rigor, reproducibility, and trustworthiness of such research, and building public-private partnerships to sustain a vibrant research and innovation ecosystem. H.V. Jagadish, or Jag, as many of us know him by, is Edgar F. Codd Distinguished University Professor and Bernard A. Galler Collegiate Professor of Electrical Engineering and Computer Science at the University of Michigan in Ann Arbor, and he's the director of the Michigan Institute for Data and AI in Society. Professor Jagadish is well known for his broad-ranging research on information management and has over 300 major papers and 38 patents. So thank you, Jag and Jing, for joining us, and welcome. So we're going to jump right into some questions, and audience, we will have some time, hopefully at the end, but we encourage you to drop your questions in the chat in the meantime. Okay, we are going to start with, let me start with a preamble, actually. Give everybody a little bit of a sense of what you all are doing at MIDAS. So MIDAS has been playing an active role in supporting scientists at University of Michigan to adopt new technologies, including a variety of generative AI models, and incorporate such technologies to increase speed, scope, and scale of research. So Jag, in a recent publication from both you and Jing, you made a compelling case for research institutes like MIDAS to play a leading role in institutional transformation, particularly in helping universities adapt to rapid advancements in AI. So what motivated you both to take this stance, and how has MIDAS approached this leadership role in practice?
Thanks for that introduction, Michaela. So let me begin by taking a moment to talk about what institutional transformation means. Now, if you think about any field, we all strive for excellence. That's what academia is all about. We're always trying to hire the best people, the smartest people, and give them room to excel at what they do. And sometimes we're successful at doing this, but everybody's doing this, and this is true of AI as is true of any other field. But this is disciplinary with respect to specific disciplines that we're trying to do. If we talk about an institution, an entire institution like a large university like the University of Michigan, institutional transformation means that across the university, there's something different that happens. And this something different has to be field specific, domain specific, appropriate to each discipline and the kinds of questions that individual researchers in those disciplines are asking. And the question is, how could they make use of AI or of data science or of any other technology when it's appropriate? Do they know what opportunities it offers, and are they able to capitalize on these? And this is something that's really hard to do well, because people are trained in what they're trained in and are not necessarily conversant with the kinds of things that come rapidly down the pike. There aren't well-established mechanisms for sharing good practices or best practices. I'll do something, I'll fool around with something will work for me, and a few of my buddies know about it, and vice versa. I learn about something that somebody knows, but this is a trickle-down dispersal network, and this isn't really an effective way if what you want to do is to have new technologies adopted quickly. And we're thinking about what, with limited resources, could MIDAS do that would really make a difference to the University of Michigan. And it seemed to us that the number one thing is institutional transformation in terms of enabling the appropriate adoption of new technologies within our scope, which is data science and AI, to advance research across the university in various disciplines.
Okay. Yeah, that's great. So I think we're going to get into the details here in a little bit, but I also want to keep in mind that the leadership in practice, right? That's a great motivation, but like, what does that look like in practice? So with that in mind, what kinds of support specifically does MIDAS provide? And how do you prioritize those services, especially given that the needs of researchers across campus with respect to AI can vary so broadly based on the discipline? Are they a STEM field, a non-STEM field? What career stage are the faculty in? What are their technical backgrounds? So what specific support and MIDAS provide? And then also, how do you prioritize those?
I'm going to say a little bit about this and then ask Jing to add more. You're right in that we can't do everything for everybody. We have to prioritize, and you'd be amazed at how much commonality there actually exists between subsets of individuals who hail from very different disciplines. So I'm not saying everybody's the same. What I'm saying is there are similarities that one doesn't expect immediately. And so a lot of what we try to do is to find common sets of problems or common questions or common barriers that we see or hear about from various people. And those are the ones that we try to address first. Also, there's a question of not replicating things that are being done by individual units in terms of the kinds of training and research support that they offer. Various departments and colleges do their own things, and we're basically trying to use our resources to fill holes in the places where we think that it would be most effective. I'm going to hand it off to Jing to talk about some examples that I think we have in mind.
Great.
Yeah, okay, sure. I can add some specific examples from, I would say, from the strategic level and then from the technical level. Some of the support that we provide really are the same as all kind of research support that you would provide to for any technology. I'm not going to go into those too much. For example, helping people find collaborators and brainstorm and find resources. I'm not going to talk about those. The specific things about AI, at the strategic level, we have been helping departments to develop AI strategy. For example, AI in emergency medicine, AI and math, and how are the departments thinking about these? What are the most important things that they need that MIDAS can provide as a university-wide organization? So I think supporting departmental strategies is a big thing. And then another thing is helping individual faculty members and students explore. So very early on, 2 years ago, we compiled this guideline for using generative AI for research. What can you do with generative AI, or what should you or should not do with generative AI in research design, in coding, in manuscript writing and presentation, and so forth. So we've developed this guideline very early on, and most recently we started an AI sandbox, and so we have a staff scientist who curates AI models for various purposes. For example, using AI models for image analysis, using AI models to review literature, and then or using AI agents to develop your next project. And so we have someone who curates these models and do light benchmarking, and then we showcase these models to really anybody at the university, and who can actually walk through these models with our staff scientists guide. And this is an approach where we try to lower the cost of exploration and also reduce the possibility of people using every model they can find and using them in totally wrong ways. And so this is another thing I wanted to use as an example. We have included rigor and reproducibility training in our current training programs, specifically about AI and generative AI. So using the hands-on approach to show people what they should do and what they should not do. And we offer a year-round tutorial of generative AI tutorial series. It's starting 2 years ago from simple things like how to use generative AI to code, to now offering, how do you build an AI agent to run your experiment. And so these are the things that keep evolving as the need of campus evolves.
That's great. I love that, because that really is something that allows this upskilling in the era of AI across campus, not just for a particular group on campus. But I did want to ask, because this does come up a lot in our community. You do mention, again, these kinds of skill building series, but do you, in kind of weaving that together with what you said about working with particular units on their AI strategy, have you done any work maybe with a unit to provide really specific faculty professional development in AI? And I'm thinking now for faculty who need to weave these tools into their curriculum, not necessarily that they're teaching students to build AI, but that AI is now so integral in every discipline. Is there any work that you guys are thinking about doing on that or already doing? And that's for Jag or Jing. I don't know which one of you want.
Yeah, please start, Jag. I think you're trying to unmute yourself.
Oh, no, I was saying go ahead.
Okay, so in terms of faculty upskilling, there are, I think, two major approaches that we're taking. One is we have developed a very intensive summer academy series. This past summer, we offered 7 weeks, starting from beginning methods to advanced topics of AI, specific AI methods used in various domains. We've started out by trying to do something domain specific, like, for example, data science and AI methods for biomedical sciences and for social sciences. This past summer, we've also tried a different model, which is a more domain agnostic training model. So we're doing both, and we'll see what works well. We also evolve these contents together as AI matures and as new AI models come out. For example, in the past couple of years, we had a bigger focus on coding, but now this past year, it's more about how do you use AI to code and how do you verify the code. And so these are the things that we're changing. So this is one set. Another set, as you all know, honestly, students, postdocs, and graduate students are on the ground doing the actual technical work. Faculty oftentimes give sort of conceptual guidance. And so this is something that we're also trying to do. And we started out doing a faculty-student connection program where the vast majority of the campus, faculty members on campus don't have ready access to students who are trained in data science and AI. Those students concentrate mostly in computer science, statistics, and so forth. And so we started a program to connect the faculty all around campus with students who have training in AI and data science. And it's been in high demand so far, and we're building follow-on activities to connect more between students between AI skills and domain knowledge. And so this is our next step.
I love that.
Jack, do you
That
want
is
to?
so cool. I
Yeah, Jack, do you want to?
empower the students and postdocs to be the trainers. That's great.
Yes.
Jack, do you have anything to add, or should we move to the next question?
No, let's move on. We only have 10 minutes.
Yeah. So I want to, this is fantastic. You guys are doing so much, but I'm curious now, in particular for the other leaders in the room, if you could share some of your biggest challenges in building and maintaining this infrastructure and all this programming for enabling researchers to adopt new technologies and new methods.
So let me take this on, and I want to talk about three factors in terms of challenges. One is hasty adoption. We already see a lot of bad signs out there, and because people are racing to adopt AI, and people are racing to publish papers with AI and so forth. And so I think the hasty adoption is actually a big challenge. How do you encourage people to adopt in the correct way, but also prevent, bad science being generated and really like adding noise to research? So I think that's a major challenge. And then the second challenge I wanted to say is a lack of conceptual understanding on everybody's part, including us, about what AI adoption ideally should look like. Because right now, all the approaches that we're taking are we're assuming that AI is just another technology to adopt, but it's not. AI is interacting with scientists at a conceptual and intellectual level. AI is telling us what information to believe in, and AI is filtering information to us. This kind of thing, and it's new, and so we still are trying to understand, and I don't think that understanding is coming anytime soon. And we're still trying to understand what an ideal adoption of AI look like. And while trying to get out of there, really, we're building the ship as we sail. And so the third challenge is resource. And university leaders and organizational leaders everywhere, right, says, okay, help people adopt AI. And so we're using our current resource, we're using our current expertise to address a very new and very big challenge. And I think these are the three challenges I want to put out
Yeah, those are those are big ones, that's for sure. I'm looking forward to seeing how you address them. Jack, do you have anything to add to that, those challenges?
Resources are always a challenge, and a lot depends on people being able to, a thing that I think has been critical for us, our success in MIDAS, has been the willingness of a number of senior university leaders to give up bookkeeping of cost benefit for their own budget lines, because so much of what we do is amortized across larger sections. And so it's been a case of persuading leaders that to trust that they're going to get far more than they put in, and for them to have the vision to see that.
Yeah, I can see that. And so, I mean, just sort of riffing on that to our next question, as for the other leaders in the audience who may just be getting started, I would ask how, what do you wish you had known when you started this work? But also, is one of your recommendations that you really need to find some of these champions for the work you want to do to socialize that across the campus and with university leadership? Because let's be honest, you can't do much without those resources, right? So how do you start that building? And what do you wish, as you were building, that you knew when you began the work?
So for me personally, I had already been working with many different parts of the university, but it has just been amazing how many more parts of the university there were than I had already interacted with and how much more I had to learn as we went along. And the University of Michigan is just an amazing and very big place with a lot of people doing very cool things in places that any one of us normally doesn't think about. And so I think that the way in which people interact with any technology and AI in particular across this has been really eye-opening. I don't think that I could have imagined many of the things that we've come across just, sitting in my office and saying, well, I generally know what these 100 different departments are and what they do. So I think just being open to this sort of thing is one major thing. Jing, you might have other things to say.
So I'll add one thing to build on what Jack said, which is the variety of attitudes toward AI and the needs toward AI means that there is absolutely not a one-size-fits-all model. If I have one lesson, that would be figure out who needs what and what are the early experiments you can do, and also what are the lessons you can learn from the doubters. And so we have had early ideas about how to build automated research workflows with AI. I think we spent way too much time trying to get buy-in and trying to get resource. In hindsight, find one small thing and start experimenting so that you can show people, this is what I meant, this is what I meant, this is what we can achieve, and then scale. And then there are definitely not lots of naysayers, and you can learn something from naysayers. You don't have to bring everyone along with you. You can talk with the naysayers, understand their concerns. Maybe you can persuade them. Maybe they can persuade you. But work on different things with different people. Start small. Don't wait for the university to give you resources, and do things small and then convince them later.
Right. The preliminary data to put in the proposal. Great, thank you. So I'm going to pause here because we only have 2 minutes left. If anyone in the audience has a question, you can either drop it in the chat real quick, or I believe the hand raising feature will work. Let's make sure. I don't know if I see everybody's, or unmute. And then while you're thinking of questions, I'm going to actually go to one that, because I think some of my last questions you both touched on, but this one I'm not sure we really got to. So, and this is kind of an opinion question, and either of you can take it first, but how do you see AI as different from other emerging technologies? And what lessons are you learning from this, this rapidly moving field? That might prepare you for other emerging needs in the future? I mean, I think you touched on it just then, Jing, but I don't know if you want to expand a little more.
I'll expand a little bit more and then see what Jag has in mind. So as I mentioned, I think AI fundamentally is different from other technologies because it interacts with us at the intellectual level. And also it's changing so much about science, how science is being done, what part of the research, what part of the research workflow is being taken over by AI, and what human scientists need to focus on, and what kind of guidance and insight we need to provide in the process. And so I think this is a question I think about all the time, which is 10 years or 20 years from now, what does scientific research look like? And how do we shape it in a way that we want? And then related in that future research ecosystem with human and AI, with academia, industry, and government, what's the best system that we want to strive for? And these are the big questions I'm thinking about now.
Do you want to add anything in the last 30 seconds?
So I want to take a step back first and say, whenever we have a new technology, it enables new things. But usually it enables new things within the scope of where it helps. And that is a certain limited context. So the universality of context is a really important thing. And that's been true for data science because almost every discipline has data. And that's even more true of AI because every discipline requires thoughtful analysis or careful thinking. So there is the universality piece. Then there is the transformational piece, which is you can do new things that you didn't imagine you could do before you had that technology in hand. And that is certainly true of AI as it is true of many other technologies. But in addition to its being a tool that you use, the fact that it impacts your own thinking, I think is really a second level thing. And this is my way of repeating what Jing said in different words. I think that it's more than the tool opened new doors and allowed us to do things we didn't imagine before. It is the tool went from being a tool to being a partner. And this is something that hasn't happened before. And we really have to understand how we benefit from having that kind of partnership.
Yeah, I couldn't agree more. And also understanding the limitations of that partnership, right? This is something
Right.
we all have to keep in mind. So we are now over time. I apologize that we got started a few minutes late, but I really, really appreciate both of you joining us and sharing your insights today. Clearly, we could have gone for another 10 minutes because I have more questions to ask, but we'll have to save it for another day. Thank you again for joining us. And thank you, audience, for being here. The recording will appear on our YouTube channel shortly. And have a great rest of your day. Bye, everyone.
Thank you. Thank you
Thank
all.
you.
Bye.